Hello and welcome to the part 3 of news and enhancements in RAW2 version 33. First, I would like to show you the new PCF import configurator. Historically, when you were importing PCF files, first step usually was required to adapt a little bit the import setting for RAW2 so that the corresponding PCF elements could be assigned to the correct RAW2 elements. As it could be that you have different sources for PCF files, you don't necessarily have only one environment file to manage, and therefore we now have created a PCF import configurator which allows to customize the configurations and manage different parallel configurations. So in the interface configuration you can create different configs, and for each of the configs you can define pipe classes so that the import can refer to the pipe classes and import all the corresponding elements, assign the correct material and standards to the different pieces so that the import is automatically much more complete than previously. The mapping table of various information from the PCF file can also be assigned to the corresponding RAW2 data, for example for the support types, and you can assign any attributes to the different settings like material, wall thickness, insulation thickness and so on. In this table you can just add new values or modify those which are already predefined, and you can pick from those available in RAW2. And the configuration files can also be exported so that you can share it with other users. And when you start importing a new PCF file, you can select the configuration you want to use for this particular file, and it's also possible to edit the existing configuration directly or create a completely new one. On the other hand, you can also do a PCF export, and you can do this for the whole system or for only the selected area or the displayed area. You can also create separate PCF files for each line. So let's have a look how to use the configurator. First step is to open the PCF file. So I would go to File, Open. I would choose the PCF file format here, go to the directory where the PCF files are located, and I will select now all the PCF files I want to import. This can be more than one file, and I say Open. Now I can choose between the previously defined configurations, and if I want to modify them I can go to Edit Configurations, and here for example I can use the last defined configuration and see how it is defined, the units, the coordinate system, the attribute assignment, the different support types, the predefined dimensions, the material assignments, insulation thickness, and pipe classes. And in the pipe classes I can define which material standards are used and tolerance standards are used for the different components. Okay, once I'm finished with my configuration I can save the changes, and now I can use the selected configuration for import. So here's the new file, and now I can check if the data has correctly been imported by using segment properties and look at the dimensions here, and I can see that the dimensions have been correctly imported. I can also see that the insulation thickness has been correctly imported, and if not I could go back and reconfigure my interface configuration for this kind of file. The next new function I would like to discuss is the transfer segment data function. When you create a new line you have to specify things like pipeline names, areas, operating data, loads, and this can be very tedious. To make it easier, if you have already a line in your system that has all these parameters correctly set, you can just take over any of this data from the segment already existing. Let's assume I've just created this small new line here, and I would like to assign the same data as in this main branch. In the main branch I can see that I have a whole set of different operating data. I have some wind loads here. I also have some pipeline name, and of course in this new part this is not specified yet, so I can now select this part from here to here. Now I would use the function edit transfer segment, which is in the edit menu, and I click on the segments from which I want to copy it. And now I've got the question which data I would like to transfer, so let's transfer pipeline name, the assignment to the regions, operating data and all the line loads. And now I say OK. And now if I check the assignment, I can go through the different settings and, for example, check operating data, and I can see that I have the same operating data in all the different load cases here assigned based on this reference segment. I also have the correct pipeline name, the same region, and all the data that I've taken over, such as some line loads. So to continue with the new features, I have to discuss the dimension dialog. Now in the installation tab you have a new entry for the material of the plating. Historically you were required to enter the density of the plate itself, of the cladding, and now you can choose from different materials like steel and aluminum and have preset densities. This makes it easier to define the line mass with different claddings. Also in the installation tab you can now specify that it is actually a plastic jacket pipe, and this opens a whole new set of parameters. You can influence the PUR thickness, the PUR density, and also the allowable stresses for the PUR and the PE jacket. This is usually used in the buried pipe calculations. You also have the possibility to add an inner lining now. Some of the pipings have a quite thick inner lining, especially for example GRP pipes, and historically you were required to calculate the influence this lining has on the density and the weight of the piping system manually. Now you can just say thickness and density of the lining, and then the inner diameter of course will be reduced by the lining thickness, so the medium density will be acting on a smaller portion of the inner section of the pipe, and the rest will be the inner lining. The inner lining usually is not considered with any stiffness. Okay, let's check this in the graphical user interface. So in the dimension dialog I can look at the installation data, and historically this would have been in the user-defined setting, so I would have to enter the plate density manually each time, but now I can just choose from steel, aluminum or PE and get the corresponding tin plate density and line masses changed here. Also, if I say this is a jacket pipe, I can now click this jacket pipe, and I have to specify the thickness of the PUR foam, which is taken as the insulation thickness if the pipe was previously insulated. The density is a typical PUR density, and now you can set also the allowable stresses and the Young's modulus for the PUR and the PE jacket. Let's also have a look at the first page, in which you can specify the inner lining here. So if you want to add an additional lining, you can give it a thickness and a density for the lining, and this thickness is taken out from the inner side of the medium, and the medium density medium weight will be calculated accordingly with the smaller inner diameter. Another new feature is that in the soil data dialog you now have additional parameters which are very often used, for example the soil cover height and the cushion thickness if in case you have an expansion cushion. So this makes it much easier to identify which soil data is used for which part. In the soil data itself you can now specify also the expansion cushions according to EN 13941. As before, you can also use IGFW 401 as an option. Let's also have a look on this on the RAW2 user interface. So if I go to the soil data dialog, I now see my soil name as before, but I can see which standard, which soil cover height and which cushion thickness is applied here. If I click on the segment soil data type here, you can now see that I can specify it according to EN 13941, type hard or type average, and you can still use the three different stiffnesses from FV401. Another nice feature is that when you start drawing and you want to choose your piping segment, sometimes you have so many segment types in your system that it's difficult to identify which is the piping dimension that was used in a certain segment. And you can now use the select segment to bring up the correct dimension. Then you click on the dimension that you want to have, and it's automatically set, so when you draw a next piece of pipe you draw it with exactly the same line. So let's see these functions in the graphical user interface. Now let's assume in this huge model I now have an extension for this small line, and I want to draw with the same line dimensions, but I don't recall exactly what line dimension it is. Now of course I could click on this line, see it's actually the type is DN25.12, and now look up the DN25.12, which would be here. So then I can draw my line. Now an easier way would be to just say here select segment, then click on the segment and then say okay, it's 2512, take the drawing pen and start drawing the next line here. Okay, I will stop here for today. Thanks for listening and hope that you tune in next time.